So we talked now about where we find these various fossil fuels and where in the world they're in their greatest quantities. Now we're going to talk about how they're actually used to produce energy, electricity in this case. And so we know that we can combust, we can burn these fossil fuels, coal, oil, natural gas. And that reaction, combustion is combining oxygen and a source of fuel, in this case the fossil fuels, to produce large amounts of heat energy and also waste products such as carbon dioxide and water and potentially other waste products. And that heat energy that is released from the combustion of these fossil fuels can be used to produce steam. And that steam, as it rises, turns a turbine, which is connected to a generator, which generates electricity. And that's the pattern that all of these fossil fuels, coal, oil, and natural gas, it's the way that they are used to produce electricity. We can see that in the model here. We have the fuel source, coal, oil, natural gas. It gets burned, combusted. The exhaust gases often go through various pollution control technologies to try to limit the amount of pollutants being released in those exhaust gases. But the heat from the burning of these fossil fuels takes water, which we see here, and boils it. As that boiled water turns into a gas, it moves through a valve where it spins a turbine. A turbine is basically something that will turn when it is acted upon by rising steam or by wind power or water power. All of those things can turn this turbine. And when you have a spinning turbine, it's connected to something called a generator, basically a coil of magnets, and as this generator spins, it produces electricity. And that process is how we generate electricity using these fossil fuels. And we can see one part of that here. Here we have the turbine and the generator. So the turbine, as it spins, anything that spins this turbine will spin the shaft, which rotates this copper wire that's surrounded by magnets, and that process produces electricity. So a turbine and a generator are what actually produce the electricity that's used. These transform the mechanical energy of the turbine into electrical energy. We also, one topic to talk about is an additional way that we have started extracting large amounts of fossil fuels from stone that contains these fossil fuels. So the process is called hydrofracking, and hydrofracking is a process that allows us to extract natural gas from rock in which it's trapped. So what's done in hydrofracking, this is a hydrofracking well, and hydraulic fracturing, basically you drill a long vertical tunnel until you get to the rock that contains the natural gas, and it's drilled also horizontally into this rock formation, so down and horizontally. And then what happens is a mixture of water, sand, and various chemicals are pumped at high pressure into this well, and it actually breaks or fractures the surrounding rock. And so the rock cracks, and there are these chemicals added into this fluid that hold these cracks open, and that allows the natural gas to escape, and then it makes its way, it's pumped out to be accessed. And so this hydrofracking process, it stands for hydraulic fracturing, has been increasing in terms of how much it is used. It's used extensively in the Appalachian Mountains. It's used extensively in Pennsylvania, where there's large amounts of gas trapped in this Marcellus shale is what it's called. And so it's been increasing, and it's actually really increased the production of natural gas in the United States because we started using hydrofracking to access these gas deposits. The hydrofracking can be controversial. In fact, it is not allowed in New York State. And that happened, I don't know, maybe 10 years ago. There was a ban on hydrofracking in New York State. It is still allowed in Pennsylvania and lots of other places. It also became an election issue in the most recent presidential election. There was talk of whether or not the candidates would allow hydrofracking to take place. Actually, both of the major party candidates said that they would. But there are risks with hydrofracking. There's several risks. A couple of things that are important to consider is it uses huge amounts of water that has to be trucked in because that water gets pumped into these wells to fracture the rock. And that material, that water, is actually contaminated, or things are added to that. Ceramic beads sometimes, sand, are added to this water to keep those cracks open. And then there's various chemicals that are added to this fluid. These are proprietary recipes that different companies use, and they don't have to divulge sort of what's in this fracking water that are pumping into the earth. And so there are other concerns as well. There are concerns that hydrofracking and fracturing the rock in these areas can lead to increased levels of geologic activity, such as earthquakes. There's the use of water, which equals about the annual water consumption of 40 to 80 cities. That water is then contaminated because of the mixture of sand and chemicals that are put into it. If the hydrofracking interferes or connects with groundwater or aquifers, it can contaminate those aquifers. The people living in areas where there's a lot of hydrofracking also have to deal with, constant trucks bringing in water, taking that water away, etc. And so there are certainly a lot of consequences that come along with accessing natural gas through hydrofracking. It, like we said here, it can cause groundwater contamination. Also can release various compounds, VOCs, that could impact human health.